Hello students, let us continue with chapter 8 quadrilaterals. We will take a look at the solved example on page 143 of your textbooks. So what has been given, let's read the question. Two parallel lines L and M are intersected by a transversal P. Show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So what we have done is we have drawn two parallel lines L and M. Given L is parallel to M. Also we have a transversal P intersecting L and M at points A and C respectively. So another point here is transversal P intersects L and M in points A and C respectively. Also we have points P and S on line L and points Q and R on line M, which is mentioned here. Now the other thing is show that the quadrilateral forms by the bisector of interior angles is a rectangle. So which are my interior angles over here? I have interior angle PAC, ACQ, then I have interior angles SAC and ACR. So we have bisectors AB and CB. So AB bisects angle PAC, AB bisects angle PAC and CB bisects angle ACQ. Similarly, for these interior angles out here, AD bisects angle SAC and CD bisects angle ACR. CD bisects ACR and AD bisects CAS. What we need to prove is that now this quadrilateral so formed by the bisectors of the interior angles, that is quadrilateral ABCD, is a rectangle. So in order to prove anything a rectangle, let's get back to the definition of what rectangles are. Rectangles are parallelogram in which any one angle is 90 degrees. So what do we need to prove in order to show that quadrilateral ABCD is a rectangle? 2 points, namely that ABCD is a parallelogram and any one angle is 90 degrees of quadrilateral ABCD. So let us see with the given data we are going to conclude that quadrilateral ABCD is a rectangle. So first of all we have L parallel to M and we have these points on line L, PAS and QCR on M. Obviously since L is parallel to M, I have angle PAC equal to angle ACR because they form an alternate pair of interior angles for parallel lines L and M. Let's write this down first. I'll say proof. L is parallel to M, therefore angle PAC is equal to angle ACR. I'll say alternate interior angles, and let's mark this statement as 1. What else do we know? That AB bisects angle PAC. So, and what is the half of angle PAC is going to be angle BAC. Similarly, CD bisects angle ACR. So, the half of angle ACR is going to be angle ACD. But what have we been given? That PAC is equal to ACR. Therefore, half of PAC is going to be equal to half of angle ACR, that is BAC is equal to ACD. Let us write this down. So, I will say, since we have written this, I will say therefore, half angle PAC is equal to half angle ACR, which is BAC, angle BAC is equal to angle ACD. And in brackets I am going to say AB bisects PAC and CD bisects angle ACR. I will mark this point as 2. But if you notice, angle BAC and angle ACD are a pair of alternate interior angles for lines BA and CD. Therefore, what can I say? That BA is parallel to CD or AB is parallel to CD. Let us write this down. Therefore, from 2 over here we can say that AB is parallel to CD. I will say alternate angle theorem, and I will mark this as 3. Similarly, now let us take a look at the bisector of other interior angles. If you notice that angle SAC is equal to angle ACQ because again they form a pair of alternate interior angles for parallel lines L and M. So let's write this down. I'll say this is the second part. I'll say L is parallel to M. Therefore, angle SAC is equal to angle ACQ. I'll say alternate interior angles. And let's mark this statement as 4. Therefore, half of SAC is going to be equal to half of ACQ, which means that angle DAC is equal to angle ACB, because they are halves of these angles, since AD bisects angle SAC and CB bisects angle ACQ, which is given. So let's write this down. Therefore, half of angle SAC is equal to half of angle ACQ, which means that angle DAC is equal to angle ACB. Because I have AD bisects angle SAC and CBC bisects angle ACQ. I'll mark this point as 5. But if you notice that DAC and ACB are a pair of alternate angles for lines AD and BC, correct? Therefore, according to alternate angle theorem, what do I have? I have AD parallel to BC. So let's write this down. Therefore, AD is parallel to BC, and let's mark this as 6. Or first I'll write down the reason. Alternate angle theorem. I'll mark this point as 6. So if you notice, from point number 3 and from point number 6, what can I say? These are holding true for quadrilateral ABCD. That means AB here is parallel to CD and AD is parallel to BC. Therefore, what can I say? That quadrilateral ABCD is a parallelogram. So my first part is proved. Therefore, I am going to say, therefore, quadrilateral ABCD is a parallelogram. And I'll say my reason as from 3 and 6. So we have proved our first point here. Now we need to prove that any one angle in quadrilateral ABCD is 90 degrees. So if you notice, I have my parallelogram here, but if you see, angle PAC plus angle CAS is equal to 180 degrees. Why? Because PS is my line and AC stands on it. Therefore, through linear pair axiom, I have PAC is equal to plus SAC is equal to 180 degrees. Let us write this down. Angle PAC plus angle SAC is equal to 180 degrees through linear pair axiom. If you notice, PAC, we have the bisector as AB. Therefore, half of PAC is BAC. Similarly, your AD is the bisector of ACD. Therefore, half of SAC is angle DAC. And what do we need? We need to prove that any one angle of the quadrilateral is 90 degrees. So we need these two angles. That is why what I am going to do is, I am going to divide here throughout by 2. What will I get? Therefore, half of angle PAC plus half of angle SAC is equal to half of 180 degrees. Correct? Therefore, what do I get? That angle BAC plus angle DAC is equal to 90 degrees. Why? I am going to write that AB bisects angle PAC and AD bisects angle SAC. But angle BAC plus angle DAC is equal to angle A for quadrilateral ABCD. Therefore, angle A is equal to 90 degrees. Why? Through adjacent, or I'll say angle BAC plus angle DAC is equal to angle A of quadrilateral, or I'll say of parallelogram, because we just proved that ABCD is a parallelogram. So, I am writing angle A of parallelogram ABCD. Therefore, one angle of parallelogram ABCD is equal to 90 degrees. Correct? Therefore, from, let's mark this equation as 7 and this one as 8. What do we get from 7 and 8? That quadrilateral ABCD is a rectangle. From, or let's say quadrilateral ABCD is a rectangle. From 7 and 8. So this was about question number 4, a very lengthy question and a little tricky. I hope you've paid attention. We'll take a look at the next solved examples in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.